So some of you have been asking, let's suppose that I want to break down a polynomial or find the zeros of the polynomial, and I don't know what any of the zeros are. And like we've talked about in class, we could truly graph this and find a zero. But some of you don't like that idea. You're like, I should be able to do this by hand, which I applaud. So what if I want to do this by hand? And then ultimately too, like sometimes the graphing calculator, it's hard to recognize, especially if it's a decimal, what that zero really is. What's a prettier way to write it? And we could work on that, but instead let's talk about finding the zero. Let's talk about finding the zero by hand. So what we're going to use is something called the rational root test. And what this is it's a way to find exactly what it says. It's a way to find rational roots, or all possible fractional roots. Possible fractional roots. And if you think about factoring, if you're ever factoring, and using maybe your area model, the most important boxes, or the boxes that you really worry about creating, are that one and that one. And then the other ones kind of fall in place and you make sure that they work out. And the rational root test works really the same way. You're going to look at what would make that orange box, which are really just the constants or the numbers. So we're going to look at the constant here. And then similarly, we worry about that lead term, that term with the highest exponent. And so we're going to worry about that lead term here. And specifically the rational root test, since we're just finding a zero, we don't even have to worry about the x there. We're just going to worry about the coefficient. So the lead coefficient, the coefficient on the highest exponent term, or the term with the highest degree. And what the rational root test says is figure out all of the factors of those two things. So for 75, I have positive and negative 75. I've got positive and negative 25. I've got positive and negative 5. I've got positive and negative 3. And then ultimately, 3. And then ultimately I've got positive and negative 1. And similarly, we're going to do the same thing with the lead coefficient. So we have positive and negative 2 and positive and negative 1. And what the rational root test says is it says take all of the factors of that constant, the orange terms there, and you're going to divide them by all of the factors of the lead coefficient. So we're going to get positive and negative 75 halves. If I could write today, positive and negative 25 halves, positive and negative 5 halves, positive and negative 3 halves, positive and negative 1 half. That doesn't look like a half. Positive and negative 75, because I'm doing the 75 over the 1. Positive and negative 25, because I'm doing the 25 over 1. I did all of them over 2. And then, I could keep going. And that finishes out our entire list. And what the rational root test says is if there is a fractional root, if there is a fraction that is a zero of that, it is one of those. But wait, you say, there are 20 of them. How in the world am I supposed to figure out which one is accurate? And that is a great question. You gotta try them. But if you're a good thinker, you just have some number sense, you don't have to try them all. So the question becomes, which one of those would evenly divide f of x? And rather than use long division, I'm just going to use synthetic here. I typically do. I know that this is my polynomial that I want to divide. The question becomes, what do I want to divide it by? Which one of those, right over here, which one of these do I think will work to divide out that polynomial? And here's what I notice. Okay, so we can get rid of a lot of options. I am pretty sure that it is not going to be 75. I am pretty sure that it's not even going to be 25. And the reason is, if you think about those, if I put those in the box to divide it out, the numbers are going to get astronomically bigger because I'm going to be multiplying by those things. Similarly, 75 divided by 2, that's 37.5. I don't think it's going to be that. I'm not even feeling like it's going to be 12.5. I feel like it's too big. And then personally, I don't think it's going to be all that small either. I don't typically try the small ones. So, I'm whittling it down. Maybe I'm wrong. Maybe I got to go back to those purple X ones, but I don't know. The other thing that I'm noticing, all of my values over here are positive. And so if I use a positive number from over here, positives, they're just going to be multiplied by positives, and then I'm going to be adding, and then they're positives, I'm adding, and they're going to blow up and just become huge. So I don't think I'm going to use any positives. And so it's whittling it down, and it seems like, I have like 6 numbers left because the positives are all out. So it really becomes pick one and try it. And I typically like to pick one kind of middling, somewhere in the middle. 5, 1, no, those are at the ends of still what I have. Maybe I'll try 3. I know 3 halves might be better, but I'd rather work with a non-fraction first and see if it works. So I'm going to try 3. Oop, I lied. -3. Remember, they need to be negative. And so if I try this, I'm going to, bring down to my first number, multiply it, 2 in the -3, and I get -6. Add them, I get -3. Multiply them, and I get 9. Add them, and I get 59. Oh, that's not working. That one's out. Might as well get rid of that yellow line too, huh? All right. So it's not -3. -3's gone. Which means I'm pretty sure +3. Actually, I know +3's gone. So that's out. Why didn't that work? Well, I wish I would have paid attention to why it didn't work. I didn't. That was a mistake. So try something else. I wonder which one will divide it. I'm still not feeling it's going to be that 5. I think that 5 is going to be too big. Maybe we try a fraction. 1/2, 3 halves, 5 halves. Let's go 3 halves. 3 halves, but -3 halves. All right. So I'm going to bring down my 2, multiply that. That would make -3. That's weird. All right. Add 0. That's why I was saying it's weird. Multiply 0. 50. 50 multiplied by 3 halves. So 50 divided by 2 is 25 times 3. -75. Which means that would be 0. So what this tells me is that -3 halves, x equals -3 halves, is one of my zeros because it worked out. And furthermore, if I factored that out, what I would be left with is 2x squared plus 50. And then that would actually be multiplied by the x plus 3 halves, because that the x equals -3 halves here means that that's our linear factor there. And so we really reduced f of x to be all of this there. Anyway, that's the rational root test. Make some educated choices and it's not so bad. It can still be long though. I get it. Have a great weekend.